There are two NAT modes based on deployment scenarios: centralized NAT and distributed NAT. In centralized NAT mode, an independent device is attached to a CR, SR, or BRAS to provide the NAT function. In distributed NAT mode, service boards with the NAT function are directly inserted into other devices, such as BRAS, to implement the NAT function. For details about the two modes, see what are the common NAT scenarios for NetEngine series routers. For details about how to configure distributed NAT, see How do I configure distributed NAT on a NetEngine series router. In this video, we will learn how to configure centralized NAT. On the network shown in the figure, a user accesses a CR, SR, or BRAS network device through a CPE. A NAT device is attached to the network device and translates a private address of an internal network into a public address so that the user can access the internet. The configuration process is as follows. First, configure basic NAT functions. Second, configure a NAT traffic diversion policy to translate a private address into a public address on an interface. Third, configure a NAT conversion policy so that NAT is performed using an address in the public address pool only for packets that match the ACL rule. Step 1. Configure basic NAT functions. Centralized NAT supports both dedicated board and onboard scenarios. In onboard scenarios, you do not need to enable the dedicated board mode or configure session and bandwidth resources for centralized NAT. This example uses the dedicated board scenario. First, enable the dedicated board mode and configure session and bandwidth resources. You do not need to manually enable the dedicated board mode for devices on which it is enabled by default. NAT session and bandwidth resources are controlled using a license file. By default, a device is not assigned any NAT bandwidth or session resources. Before you configure NAT functions, adjust NAT bandwidth and session resources. Then, create a NAT instance named NAT1, and bind the service instance group named Group1 to the NAT instance. Finally, configure a NAT address pool and set the public addresses that can be allocated to 11.11.11.101, to 11.11.11.105. Step 2. Configure a NAT traffic diversion policy. A centralized NAT traffic diversion policy can be configured on an inbound or an outbound interface, but not on both at the same time. This video uses a NAT traffic diversion policy on an outbound interface as an example. First, configure an ACL traffic classification rule to allow only packets from network segment 192.168.10.0/24 to pass through. Then, apply the ACL traffic classification rule to the outbound interface of the NetEngine series router so that only hosts on the internal network segment 192.168.10.0/24 can access the internet. For details about how to configure a NAT traffic diversion policy on an inbound interface, see the following configuration roadmap. Step 3. Configure a NAT conversion policy. This step is required only in the dedicated board scenario. Configure the device to use addresses in the public address pool to perform NAT for packets matching ACL 3001. NAT will translate the address of a packet using the public address pool only when the packet matches the ACL rule and the behavior defined by the rule is permit. After the preceding configurations are complete, run the display NAT user information slot command to check NAT user information. The command output shows that the CPE IP address is 192.168.10.100 in the address pool for user access, and the NAT instance is NAT1. The post-NAT public IP address is 11.11.11.102 in the NAT address pool. This indicates that the configuration is successful. The private address in the user packet can be translated into a public address so that the user can access the internet. That's all for this video about how to configure centralized NAT on a NetEngine series router. Thank you for watching.